students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, we will learn the applications of green chemistry. So, here are the topics: synthetic applications of Sono chemistry, that is the ultrasound assisted method that we have discussed in the previous session. Then applications of green chemistry, and a part of applications, engineering applications of green chemistry. So we will see these applications with examples. So the first application for the Sono chemistry or the ultrasound assisted method, wherein we use the ultrasound or sonication for the synthesis. So esterification is one of the application where esterification is generally in conventional way is carried out in the presence of catalyst like sulfuric acid. So this is acidic medium we are using for synthesis of esters. But this reaction takes longer time. So it takes very long time, and also yields are not satisfactory. So they are very low. Yields are very low. So what happens when we use ultrasonication? A simple procedure is proposed wherein esterification of variety of carboxylic acids. So carboxylic acids, variety of carboxylic acids can be esterified with alcohols. So different alcohols at ambient temperature using ultrasound. So this is helping to achieve with very less time and also at room temperature. So these carboxylic acids will react with alcohol and form esters. So one of the example is the esterification of enzymes. So biosalicified enzymes like virylic acid is converted to ethyl virylate. So it is forming an ester under ultrasonication. So this is very simple procedure when compared to the conventional method that is taking longer time and also yielding very less yield. So under ultrasonication, this symbol indicates the procedure, the process is under ultrasonication. Sonication is used for the synthesis. So simple synthesis is used for esterification. Then is the saponification reactions. So saponification we generally use in many of our daily usage like soaps that are obtained. So this saponification reaction is very important. Ester hydrolysis is done to obtain. So it is frequently affected under aggressive conditions like very high temperatures or alkalinity or any other acidic conditions will affect this ester hydrolysis. So it can be conducted under milder conditions when sonication is used. So in order to dissolve or the hydrolysis to take place, we use aggressive conditions. But what happens when sonication is used? We can use milder conditions. So example, methyl 1,2,4 dimethyl benzoate. So this upon saponification with a frequency of 29 kilohertz, sonication under sonication gives 2,4-dimethyl benzoic acid. 2,4-dimethyl benzoic acid with an yield percentage of 94% compared to 15% from the conventional method. So conventional method is giving only 50% yield. So yield is low. So this is very good example. Like sonication is improving the yield, also decreasing the time like only for 1 hour. So this is the normal process. When we do in the normal or the conventional process, the yield is very low. So this one methyl 1,2,4-dimethyl benzoate under ultrasonication, hydrolysis takes place in within 60 minutes and give rise to dimethyl benzoic acid. So this is giving an yield of 94%. Next example is the hydrolysis or solvolysis of tertiary butyl chloride. Tertiary butyl chloride in aqueous alcohol is also studied using sound waves. So, using sound waves or sonication. So, they have also used sonication for the tertiary butyl chloride and for obtaining the product. So, this increased the rate of the reaction. Rate of reaction is increased. Rate of reaction is increased. So, this is under sonication. Under sonication, the hydrolysis is quick enough and also the rate of the reaction increases with less time. So, this is how we simply use a cleaning bath for any applications like saponification reaction. Then is a Federal Craft acylation, which is done by substitution reaction. So, this Federal Craft reaction is most widely used in synthesis of dyes. So, dyes are the applications wherein Federal Craft reaction takes place. So, Federal Craft acylation of aromatics is facilitated by sonication. So, it is also done under sonication. So, under sonication, an application of Federal Craft reaction is used in carbon bond formation. If you see here, there is carbon-carbon bond formation or the cycle, the group, there is an attachment of ring attachment or addition, and also there is addition of other groups. So, there is formation of carbon bond. Carbon bond is taking place. Formation of carbon bond. So, this will give an yield of 75% under Sono chemical reaction. That is nothing but sonication or ultrasound method. So, this is the other example, the practical example is the triaryl methane and xanthine dyes. So, there are several reactions that are used using ultrasonication. So, that will be obtaining dyes. So, one of the example is the thymol phenolphthalein. So, it is also used as a pH indicator and from two equivalents like thymol and phthalic anhydride. So, these are the reactants that are used under sonication gives rise to dyes. What dye? Thymol phthalate. So, this is the dye that we obtain under sonication. Simple reaction of sonication. Then is the addition reaction. 1,4 addition to alpha beta unsaturated carbonyl compounds is traditionally carried out by organocopper reagents. So, conventional method what we are using? Conventional method we are using organometallic compound. So, nothing but copper here. We are using a copper reagent. So, the significant improvement in yield. The yield is improving here. 89% of yield is improved by using sonication bath. The reaction is similar with the organometallics, but under sonication, the reaction is improving. Under sonication, reaction is improving. The yield is 89%. Next is the Inalkylation reaction. That is, secondary amine can be alkylated under sonication in the presence of phase transfer reagent. So, when the reactants are immiscible, we use phase transfer catalyst. So, phase transfer catalyst will improve the reaction. So, polyethylene glycol monomethyl ether is one of the example. So, in this reaction, benzene pyrrole on methylation with methyl iodide. So, methyl iodide is used in toluene in the presence of potassium hydroxide, toluene, and PEG, polyethylene glycol. Polyethylene glycol gives corresponding N-methyl ether. So, this is giving an yield of 65%. So under normal condition it is only 60%, and there is an improvement in the yield of about 65% within 30 minutes of time. Within 30 minutes of time we are obtaining this reaction. Then is a coupling reaction. Sonication is effective in promoting the homocoupling of organometallic intermediate obtained by reaction of alkyl aryl or vinyl halides with lithium wire in tetrahydrofuran. So that this is used with lithium wire. So no reaction takes place in the absence of ultrasound. So there is no reaction without ultrasound waves. So that is obtained from bath. So this reaction is only carried out under ultrasonication. So what happens here? The reaction is enhanced. The reaction is favoring towards the products with homocoupling of these organometallic intermediate that is formed by reaction of alkyl aryl or vinyl halides. These halides with lithium and tetrahydrofuran under ultrasonication. There is an attachment of rings with the ultrasonication that is being used as a synthesis process. Next is a Cannizzaro reaction. This is also an important reaction, whereas under heterogeneous condition it is catalyzed by barium hydroxide. Barium hydroxide which will increase the rate of reaction. Rate of reaction is increased with sonication. With sonication again. So what happens here? The organic and inorganic molecules get together. The reactions takes place under ultrasonication. So we generally use low intensity ultrasound. So here the yield is 100%. 100% yield is obtained after only just within 10 minutes of time. So whereas there is no reaction without ultrasound. That is used. So this also is a very good example for the green synthesis using ultrasound method. Next is Azan-Michael addition of nucleophiles to alpha beta unsaturated compounds. So what happens here? Here the heterocycles, synthesis of heterocycles takes place. Synthesis of heterocycles under via this addition, Azan-Michael addition of nucleophiles to alpha beta unsaturated ketones, esters and nitriles. To form carbon nitrogen bonds. So it will either form carbon nitrogen bonds under ultrasonication with aqueous media. So high yields are obtained in water like 98%, as well as it is also above 90% like 93% even if there is no solvent that is used. Solvent free conditions also the reaction takes place under ultrasonication with an yield of 93%. So this is also a very good example wherein there is a formation of bond, carbon nitrogen bonds, due to which the synthesis of N heterocycles takes place. So this is also a good example wherein we can consider the ultrasonication as the synthesis method. Then is the Barbier-Grignard type reactions. These are usually referred as transformation, so in which organometallic reagents serves as nucleophiles forming carbon-carbon bond. Carbon-carbon bond takes place. So this is a formation of carbon-carbon bond wherein we use organometallic reagents. So that will help in the formation of this carbon-carbon bond. Addition of this carbon-carbon bond is forming due to the nucleophiles that are present in the reaction under ultrasonication is favoring the process or the product. Next is Ullmann type coupling reactions. Here the aryl cycles, the reaction takes place. So in this type of coupling reaction occurs at low temperatures and short time in most quantitative yield with probe sonication. We have seen that two different types of sonications, probe sonication and bath sonication. So bath, using ultrasonic bath, and probe. What happens in probe? We are inserting the probe into this solution that is present. So here it will induce the reaction directly to the reactant. So there is no transfer of energy from the vessel to the solution. It is inducing the effect directly to the solution. So it will take very less time with low temperatures reaction. So here aryl or vinyl compounds with halide, containing halide, reacts with a nucleophile, forming either carbon nitrogen bonding or carbon oxygen or carbon carbon bond formation. So these are used in the gas sensor applications. So whenever we are doing some process, when it is cost effective and it's short time, which is having a tremendous demand. So gas sensors are nowadays very applicable in industries and also domestically. So these are very useful. So this reaction is useful because it is having low temperature process and also short time. Next is the Simmons-Smith reaction. So sonochemically activated metals greatly improve the reactions of halides with olefin to produce cyclopropane derivatives. So cyclopropane derivatives are obtained with metals, activated metal couples. So it will react alkanes on reaction with copper zinc couple, or methylene iodide will form cyclopropane, zinc iodide and copper. So the rate of reaction improves again. Rate of reaction increases. So this is how it will help. The sonication will help in increasing the rate of reaction, so that it obtains the products within less time. Next comes the applications of this sonochemistry. So like these are used in the synthesis of composites for the energy storage applications like batteries or supercapacitors. Then it is also used for the preparation of platinum, ruthenium nanoparticles, gold or platinum nanoparticles for the fuel cell electrodes. Wherein these are used as charge carrier extraction, charge carrier extraction helps in charge carrier extraction because of its noble metals that are used. So these are used, having wide applications in fuel cell electrodes. Then synthesis of copper oxide, graphene oxide, iron oxide for lithium ion batteries. So we have lithium ion batteries wherein we use one of the electrode with metal oxides as one electrode. So therein we use graphene. Nowadays graphene is very trending, so the sonication process of exfoliation is also easier method. Sonication in graphene exfoliation is the easiest method for obtaining graphene. So also the intercalation of this graphene into the matrix is also, or the metal oxide matrix is also very easy using the sonication process. Then primary binary ternary nanocomposites, which have good specific capacitance, power energy density and cyclic stability, applicable for electrode material in supercapacitors. So this sonication will also improve the power density, which is important for any battery or supercapacitor applications. So charge discharge cycles that we study, cycle like charge or discharge cycles that we study during supercapacitor manufacturing will give us the result. So under sonication, when the product or the metal is deposited or the compound that is manufactured is used, it will improve the cyclic stability, so that which has good specific capacitance and also power density. Then ultrasound finds its applications in biomedical devices like HIFU for targeted ablation of cancerous and unwanted tissues in the body, making treatments easy and less painful. We see like ultrasound is also used for baby scanning. So whereas that has scanning that has high frequency, but with the lower frequencies it can also be used for ablation of cancerous tissues can be ablated and removed. That gives a very less painful treatment to the patient. Next, sonoporation. So this ultrasonication, which produces acoustic cavitation, that we have already seen, the cavitation that a bubble is growing and implosion takes place. So this will increase the permeability of plasma membrane. So that also increases the uptake of DNA into the cell. So this is how sonoporation plays an important role. So sonication is increasing the uptake of DNA molecules into the cell. Sonolysis, application in purifying water because of formation of reactive species. So what are the reactive species when it forms with water? Radicals. So hydroxyl on the hydrogen radicals that is forming. So this will increase the purification of water. So therefore, sonication can also be used in purifying water with ultrasound. Then what are the advantages? Ultrasound assisted method aids in preparation of uniformly distributed and uniformly sized nano composites in short time and utilizing less energy as compared to methods like mechanical vibration or attrition or electrodeposition. So it takes very less time and utilizes very less energy, like ultrasonication bath itself utilizes less energy. So it is very less compared to mechanical methods or electrodeposition technique. High reaction rates can be achieved using sonochemistry, resulting in time-efficient synthesis. So reaction rates are also high, so that because of that only the reaction time is coming down. So with sonochemistry, the time-efficient synthesis can be done. Then enhanced properties were observed in the field of kinetic selectivity, extraction, dissolution, filtration and crystallinity. So whenever the mixing is good, obviously the group selectivity is done, like reaction of the reactants favors. So the selective addition or substitution of reactions takes place, and dissolution also occurs, filtration, and crystallinity is good. Good crystallinity is obtained from the compounds synthesized from sonochemistry. It also acts as a catalyst, nothing but it is favoring the reaction and the rate of the reaction is increasing. So the process is acting as a catalyst and doesn't have a need to change or replace at any regular interval. So it is eco-friendly. So certain nanoparticles are already synthesized. So when we compare with the conventional methods, it will take only 20 minutes, whereas the conventional method will take around 4 hours of time for the synthesis of these nanoparticles using a conventional method, traditional methods. But with sonochemical method or ultrasound method, it will take only 20 minutes time. Then it is also having increased yield and average particle size, which was due to rapid micro mixing and thus fast reaction. Due to its fast reaction and micro mixing, the average particle size is similar for all the particles. So there is no agglomeration of any particles that is taking place within that compound. So energy efficient, as it saves 92% of energy. Very less amount of energy is required for this ultrasonic bath or probe method. So it really acts as an energy efficient method for synthesis of compounds. Then as engineering applications, these are eco-friendly And the design of manufacturing combusting process, it reduces the air pollution because we are reducing the wastage, and gases, hazardous or harmful gases are reduces reduces the gases that are harmful. So improving industrial process to eliminate waste and reduce consumption of organic solvents. Whenever we are reducing the consumption of organic solvents, it will remove the additional steps. Removal of additional steps. What are the additional steps we are using? Regeneration of solvents. Then what are the recrystallinity of material, that is the synthesized recrystallization. So these are two examples of additional steps that are to be used when organic solvents are used in the synthesis. So these two can be avoided if green synthesis is opted. So new methodology was developed by engineers that the conversion of lignin into useful chemicals, antioxidants and medical compounds. So engineers also established chemical production processes which led to reduce energy, water consumption, then minimize the byproducts and even noise reduction. So if we are using ultrasound method, for example, ultrasound method will produce less noise. So even in the production plant. So therefore noise pollution can also be reduced. So the engineers provide chemical processes which give adverse array to valuable products and materials for healthcare. So some of the examples we'll see in detail, like solution to turn turbid water to clear. So we are turning turbid water to clear with green method. So what is that green method? Tamarind seed kernel powder. So we generally discard tamarind seeds after our usage in the domestic area or in the agriculture area as a waste. So this can be used, the powdered kernel seeds can be used for purifying water, like from the municipal or industrial waste can be cleared, can convert the turbid water into clear water. See this water before the addition of treatment of water with kernel powder, and after it is treated, it is clear. So that is how it is used. The green process or the method is used for converting this turbid water into clear water. Next is the solar array. Any solar application is the best example for green chemistry because it will convert, it has abundant sunlight. We have abundant sunlight that converts energy from light into electricity through photovoltaic panels. So this is a very good example wherein we are investing only once and we can use it for much more time when compared to the other fossil fuels. So this is one of the green method or the green chemistry that we are using for conversion of light energy into electricity. Then is the reusable water bottle. So another invention is the water bottle. This is a type of bottle where once we use, we have to crush it and throw back. But there are reusable water bottles that are invented, so that will reduce plastic waste in the environment. Then building with green technology. So the vertical gardening is the best example of green buildings, wherein it has reclaimed materials, passive solar design, natural ventilation, green roofing. So all these, when natural ventilation is used, we need not switch on the fans or air conditioners. Solar design so that the fossil fuels can be protected. Then the materials that we are using from the natural sources will reduce plastic or the other earth materials. So this is how we reduce the depleting materials from the atmosphere or the earth. So green roofing is also a technique wherein we mostly avoid the usage of electricity, so that it will save the power and energy for the next generations. So this is a good concept wherein green buildings is trending in nowadays for obtaining very time efficient and also energy efficient buildings. So it reduces heat, create healthy atmosphere, space utilization, especially for gardening. Each flat has some space for gardening, that also provides healthy atmosphere. So it has good maintenance, so it can be maintained easily when compared to other buildings. Then is the dry cleaning of clothes. So generally for dry cleaning we use perchloroethylene for dry cleaning the textiles or clothings. So this will really pollute the water resource. How does it happen? Because it goes into the drain and through that to the underground water. So that will cause cancer to the humans. So to solve this problem, liquid carbon dioxide and a surfactant is used for dry cleaning purpose. So this will reduce the use of this organic compound or perchloroethylene, that is a cancer causing agent. So that is how we can reduce the usage of harmful materials. Next is the insulation of house. Based on EPA estimates, Environmental Protection Agency estimate 10% of household energy usage a year is due to energy loss from poor insulation. What happens if there is no proper insulation? The room gets heated up. So we switch on air conditioners. So 10% of our usage, household usage, is because of this poor insulation. So there is one method that is from the green chemistry, wherein from the natural wood we are delignifying the wood that is obtained from the trunk of the tree, delignifying and treating with some organic solvents. We are making it porous enough so that when mixed with the polymer will form porous and lightweight material that can be used in insulation. So if we see this is the aerogel that is formed. This is the aerogel insulation that we are using. This is the facing board into the house. This is inside and this is outside. So in between we have this aerogel. So what happens? The walls will restrict the heating up of house. So we reduce the power that is being used. So this is how the natural source is used for making aerogel, so that will use in the insulation purpose. So this is how we can reduce the energy usage or the power usage. Then is the pharmaceuticals. So in pharmaceuticals also there are so many green syntheses that are being invented or discovered to obtain good reactions or the good outcomes with no byproducts or no harmful effects. So another notable drug that requires less waste to produce is the chemotherapy drug. Chemotherapy drug nowadays we are using widely for the cancer disease. So for that we use paclitaxel, or also marketed as Taxol. So this Taxol is used in chemotherapy. So where is this obtained from? This is obtained from a trunk of a tree, yew tree. So this tree trunk is used in extracting chemical that is present, so that this drug is usually present in this trunk, which is very poisonous. So this tree, the flowers, leaves, trunk is all are poisonous, but these are used in cancer curing the disease by chemotherapy. So for this they are extracting the chemical by killing the tree. They are killing this tree because this is used in drugs. But in the green chemistry or the green synthesis method, what we are doing, we are making the drug from growing tree cells. So these tree cells can be made in the laboratory in a fermentation vat. So we just need its stem cells or the tree cells to obtain the drug. So for that we did not kill the whole plant or the tree. So we can only just grow the tree cells in laboratory and obtain the drug. in that way we save the environment and also the plankton, and also use it for our human purpose. So this is one of the best example in pharmaceuticals. So these are the applications of green chemistry on Sono chemistry, that the method that we use. So in the next session we will start fuels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.